Hi there, good afternoon and welcome, and thank you for joining us for April's edition of our community event. Coming up today, we've got a quick introduction to some of the ways that you can engage with us throughout the community, where you can find us this month at events, and some other information that you might find useful. After that, we've got an intro to Progress software with Stefan Lefrenick. So he's going to be going through the entire sort of software suite that's within Progress. That almost goes right through the technology stack. Then we've got an introduction to Corticon and a deep dive into the MarkLogic integration with Seth and Jim, followed by a Q&A afterwards. If you want to ask any questions, feel free to use the questions tab on the should be right hand side of your screen, and we'll get through to those at the Q&A. If there's lots of questions and we run out of time for whatever reason, then we'll make sure to reach out to you afterwards to make sure you get a response to those. You can join us in various different places. There's lots of different resources. We've got a community playlist to find this or any other of our shows on demand. We've got a new ideas platform, and that's proven really popular. We've already got 7 ideas under review. 1 is actively in development at the moment, plus a whole host of other ideas that are coming through on there as well. I think we're near 50 new ideas for the platform, so please keep those coming through. We've got the community portal where you can access all of our documentation, plus you can find announcements for events like this and other things. And then finally, we've got the community forum where you can ask questions to our team of expert moderators, both internally here, but also in our partner network as well. Community feedback is really important to us, so if you've got any questions or if you've got any ideas that you'd like to say to us, then please feel free to fill out this survey at the end of this presentation. So coming up, we've got a couple of events coming up this month. One is From Text to Value, pairing text analytics with generative AI. This is kind of a follow-on to a number of these events that we've done, and you can check out the generative AI playlist on our YouTube channel. Then we're at GeoInt 2024, and then we're going to be having MarkLogic World Tour. So MarkLogic World's been, I think the last one was 2019 when we were in person. So we're kicking this off in Amsterdam. Later on in the year, we'll actually be in Bethesda, but for this first event on the 16th of May, we're going to be in Amsterdam in person. So please feel free to join us at the website. If you want to get to any of these events, go to progress.com/events or /webinars, and they'll be listed there. So without further ado, I'm going to hand it over to Stefan Lefrenick, who will be discussing Progress, MarkLogic, and more with an update from him. So Stefan, if you could join us on camera.
You're on, Phil. Thank you very much for the introduction.
No problem at all.
So taking over from here, good day, everybody. So my name is Stefan Lefrenick. I run the global sales organization for the application and data platform business in Progress. That is excluding the federal business because it has some requirements regarding clearance and working with cleared people. And what I like to do is to give you a brief introduction to Progress Software and provide some background on our company. Moving to the next slide, starting with our vision and mission. Our vision is really to propel business forward in the technology-driven world. So what we really like to do is to make our customers more agile in taking advantage of new technologies without really having to completely re-architecture or redevelop their data platforms and applications. And we do so by being really the best provider of the best products to develop, deploy, and manage high impact or enterprise applications. We are a global company having and serving customers all over the world and in almost any vertical where they rely on our products to run their businesses. Going to the next slide. Yeah, click on it a bit more, Phil. Yeah, and we have the 4 categories where we have product offerings. The first one is really about creating and delivering engaging digital experiences. So the interface to the end users and also their digital customer journey. The second category is about managing content and applying business logic and insight. That is also the topic of today. Then data platforms, managing and leveraging structured and also unstructured data. And then the last category, a bit further away from the conversation of today, is that we also have a complete infrastructure management portfolio to ensure reliability, availability, and also performance for deploying applications and data platforms. Going to the next slide, on applications and technologies, we see that the must-haves for customers are, or at least should be, is to have experiences for end users that are truly engaging and easy to use. And so it doesn't matter if they are internal or external, so coming in through a web portal or working on enterprise applications in company or in the supply chain, that doesn't matter. The second piece is really that applications have to be intelligent enough to deliver content in context. So it's really about understanding the business and user requirements to deliver a seamless experience. Organization must do this also at cloud scale with systems that are always on and equipped to service thousands or even, I would say, millions of users. And as requirements are constantly changing, organization must also be agile and ready to adjust and tap automation to act faster. Then, of course, everything needs to be reliable and secure. This should maybe be on top, as this is a top priority for CIOs and business leaders these days. And getting to the next slide is really an overview of how we see having the right architecture in place for applications. Maybe you can click on it. Yeah, there we are. So starting at the bottom of the slide and then going up, it all starts with data and having the right data platform in place. And this is also really our background and where we come from, with leading technologies like Data Direct for data connectivity to almost all kinds of data sources. As you can see, we also provide a secure file transfer product to exchange files in a secure way. And where Progress really originates from is a relational database and application development platform. And this is a large and important part of our business, with thousands of customers and application partners building mission critical applications every day and rely with their business on them. And so the continuity of Progress is super important if you're an application provider developing applications and having to rely for the coming decades on a company like Progress. And then, of course, with MarkLogic, we now have an addition to also address non-structured data in the best way possible. Then in the second layer, this is really about content, logic, and insights, which is also a critical piece of the architecture where you really need to be able to handle changes on business rules, business processes, and required application functionality in the most productive and efficient way. And productivity and efficiency is really important, thinking about the shortage on developers and analysts there are, and it's already for a couple of years. And there is always change. So for this event, we will go deeper into handling business rules with a product called Corticon. But there are also other elements like handling semantic data or metadata in non-structured data sources with the product Semaphore, and that also came in through the acquisition of MarkLogic for Progress. Also content management and personalization in online portals and web systems, where we have a leading product with Sitefinity, which is also a product we use for building all the websites for the World Health Organization, handling also a massive amount of visitors and users during the COVID time. This is also certainly where you see a huge requirement on engaging experience, and not only over the web, but also on other interfaces like mobile applications, like chat, and also new technologies are coming up fast in this area or space. And then on the right side, you see that we have an offering, as I said in the beginning, on infrastructure management, and that's really to optimize availability, performance, and also protection of IT infrastructures, hosting applications and data platforms. With this picture, I like to say that we provide a complete platform for application data platforms, but also all the components or the individual components in our offering are best in class and can also be implemented in a heterogeneous architecture with non-Progress components. So it's not that you require Progress components only to implement a product like Corticon, but it fits well in other architectures. Going to the next slide, that's really about our strategy. Our company strategy is centered, of course, around helping customers achieve their goals, and that whole has then 3 pillars. First, we invest and innovate in our products, but also in our people, and also how we run the business. It's really about to be more differentiating and also add more value with our existing products and our people. Second pillar is to continue to serve a broader set of customer needs, where we look to acquire and integrate other companies that have, of course, excellent products, happy customers, and great employees. Really a strong requirement when we do an acquisition. And this accelerates also our ability to serve you better. And then the third pillar, we focus on your success. And success is built on helping customers like you in achieving your goals. So it's really a customer-centric approach, and therefore also to serve you being more successful. Going to the next slide, about customer success, you see that we serve 70% of the Fortune 500 customers. That means more than 100,000 enterprises with over 6 million business users using our technology. You see also that the retention rate or the net retention rate is over the 100%, saying that the customers are very loyal and are expanding their usage within their companies. And we serve over 4 million developers, so there is a very strong community we serve, only getting bigger also through acquisitions like we did with MarkLogic. Next slide is that we give you also an insight on where we are. You see that, as I said in the beginning of the call, that we really have a spread throughout different kinds of verticals, financial services, industrial, and that we serve also leading companies within these verticals across the world. Going maybe to the last slide to keep it a bit short, is that we are also strong in our financials and have therefore also the ability to execute very strong on our strategy. We are a public company, which means that we are transparent to the market and also to customers on financials, but also the outlook. We are listed on the Nasdaq in the US, so you can see for yourself also how we do and how investors and analysts look at us. Here you see that we are a growing company. We now have a revenue of about 700 million. The target is to be at a billion in 2 years' time. That says something about the growth. With strong operating margins, but also investing 80% back of the revenue into our existing products. We have 2,500 employees across the world, so a good coverage with the right languages, and also certainly also very important is a net promoter score of 34, where 30 is already very good. So all in all, with a strong financial, strong people, strong products, we hope to have a successful offering to you and make you more successful. And that's it from my side, Phil.
Stefan, thank you very much for that introduction into the Progress suite of technologies that, like you say, goes right through the application development stack there. So really interested to see. Right, if you've got any questions, Stefan, please put those in the chat and we'll get to those at the end. But we'll move on to our main feature today, which is Corticon. So gentlemen from Corticon, if you could switch on your cameras and join us. I'll make Seth the presenter. And Seth, it is over to you. See your screen, Seth. I think you just need to come off mute.
Ah, yes. Thank you.
There we go. Perfect.
Okay. So thank you for having me. My name is Seth Meldon. I'm a principal solution engineer here at Progress, focused on Corticon. I'm joined by Jim Arsenault, who is the head of product management for the Corticon product. I've been working with Corticon for about 6 years now, various different capacities, and really find the product a lot of fun to work with. Jim, even longer than me. So we actually are presenting today, coincidentally, on the same day that we have a brand new release of one of the ways that you can use Corticon. That release comes with something tailored specifically for MarkLogic, which we're quite excited about. Let's just start with a kind of level setting of what Corticon is, also just kind of the general technology area that Corticon places itself and how we differentiate, and then ultimately run towards a live demo and hopefully talk through how we can, the different ways that you can incorporate Corticon into your MarkLogic data platform. So if you're familiar with rules engines, Corticon is one of them. Rules engines aren't a brand new technology. I think a lot of the proof is in the pudding. So I like to kind of talk about, sure, what Corticon is and does, but if you have a particular use case that you think is potentially interesting for a rules engine, I think our ability and Corticon's capability to really spin up and the time to live for a given use case is quite impressive. So that really differentiates us, just the development time and how quickly we can build stuff with Corticon. Ultimately, what a rules engine is, though, and what Corticon tries to solve for specifically, is to enable the people who are most familiar with the rules to be the ones implementing rules. So whether that be for responding to regulatory changes, programmatic, external architectural changes, or just trying to adhere to industry-wide standards, be it in healthcare or insurance, other places where interoperability is increasingly a baseline requirement. Corticon is well suited to enable fast application development without needing to be a developer. It does this by, again, enabling the people who are the most familiar with the rules, not necessarily the people who are most familiar with application code and needing to develop the application code to operate upon it, to build decisions that operate upon that data. Corticon really enables the collaboration of the people who know the rules best with the IT product line managing the deployments of the automations that those business users are able to build from it. So I briefly want to touch on a few of the, I'm not going to touch on the use case specifically of any customers here. Mostly I show this slide, so whichever colorful logo here catches your eye, if you look at one, then look elsewhere on the screen at another one. Odds are those two businesses have just about nothing in common, other than being in a decently highly regulated industry and or having quite high availability and high complexity requirements related to their day-to-day operations. These are all Corticon customers that ultimately were looking to leverage a tool that would enable those complex rules to be managed by the people who know the rules best, not necessarily one and the same with their IT developers. So I'm going to talk through a bit of kind of what we do in Corticon and start to shape the picture of what how Corticon can be used within an environment that is heavy on MarkLogic or heavy on any other technology out there. Really, with Corticon, what we're doing is basically defining rules that are going to change data. Instead of having a endpoint that might take in information about, say, a vehicle make is a Saturn. I didn't want to offend anyone, so I tried to use a relatively obsolete vehicle make there. But if a vehicle make is Saturn, then assign it the theft risk of, or the high theft risk of the value false. So what we're doing is defining various different conditions, which when met will result in a given action or two. This is ultimately going to be defined in this user-defined vocabulary, as we call it. Those business terms, vehicle and make, those are all user-defined business terminologies. And while we're authoring and ultimately generating all these rules from straight up business rules in the user's most comfortable language, what gets generated from that is runtime code that is extremely interoperable, can be run in a variety of different environments. But before we even get to the stage of actually deploying code that we think is right based upon the rules having been written by people who should best know whether or not they're right, we have a whole host of capabilities built into the product to automate the testing and really test early and often throughout the implementation of rule projects in Corticon. So before we even get to stages like, say, defining test data to identify if indeed a vehicle's make is Saturn, are we receiving back a result of some change data specifying that now the high theft risk value is false. Before we even get to that stage of testing that with test data, we have click of a button checks for common gotchas that typically wouldn't be found until later in the development cycle, like are there potentially overlapping conditions that are producing distinct outcomes that should not be distinct. There should be a greater degree of determinism oftentimes in rules. And so with Corticon, we're really going to do everything to ensure that as early as possible in the creation of these rules, we're identifying any potential logical inconsistency that's being produced from them, so that when we're ultimately ready to generate these rules into code and operationalize them into either a web service or a Java web service on exposed as a web service on a Java application server, or just running Corticon as a self-contained JavaScript bundle, say directly within MarkLogic as a JavaScript function, we're able to have a clear distinction between how the rules are written and the runtime code, while also ensuring that the runtime code is entirely self-documenting. There's no distinction between the actual behavior that's been defined within this logic and the documentation of that logic, because the logic itself is created in the documentation. It's created with business rules, not with application code. So when we generate this Corticon decision service, ultimately at the end of the day, again, it's just going to be effectively an endpoint. It's going to take data in, it's going to change data based upon rules that have been created by business users. So effectively in the MarkLogic world or any other, it is a data API operating upon data. When various different conditions are met, other actions are going to be taken, whether that be adding or changing or creating new data. Now, the other thing that is quite useful with Corticon, and it kind of illustrates a lot of the value that Corticon gets from the broader Progress portfolio, is you may be familiar with the product line of Data Direct, which we're not going to get into too much, but I bring it up because Corticon builds in a whole host of very mature data connectivity drivers, which allow for codeless connections to external data sources. All of that to say, let's say I'm indeed going to be quoting a perhaps car insurance policy for this Saturn, this individual Saturn. Maybe I want to go to a vehicle database to check what the latest resale value is to determine what the cost might be if there is an accident of that Saturn. Well, with Corticon, we can connect to, say, relational databases or even REST endpoints in order to retrieve data or write back data to external data sources. So the client application doesn't necessarily need to be passing in all of the requisite data to make a decision from. Corticon can likewise handle the retrieval or writing back to external data sources as part of that execution. So let's actually talk about and apply how this might work in a scenario that I think is, again, as we saw from that logo slide, not specific to Corticon. Auto insurance is not a specific field that Corticon is built and bred specifically for, but by virtue of the way in which Corticon helps you solve for complex business rule problems, regardless of the domain, it is well suited for a variety of different use cases. All that to say, the reason I'm showing an auto insurance one is hopefully a broadly applicable and understandable general set of rules for this audience to kind of get up to speed on how we might use it and how it could be applied to your given business. Now, I know we have a global audience, but nonetheless, presumably there's a lot of overlap in terms of the use case here. So this slide here is actually, I took this just yesterday from what are constantly changing regulations in the US, specifically every state in the US. So as anybody who drives knows and has ultimately shopped for car insurance, it can be somewhat invasive as far as the sort of data that is being used in order to quote. It always bothered me as a young male driver that I was being profiled as such and my rate was always higher. Well, in the US, every state has its own manages the legislation related to what auto insurers can and can't do, what they can and can't rate a driver for as part of their rating policy. So if I just scroll through here, these are all the different criteria upon which auto insurers, depending on the state, can or can't judge a driver's eligibility and what their risk level might be. These are all factors that they can or cannot take into consideration. So this is a good glimpse into why Corticon's used for a lot of different state government programs in the US, especially in health and human services as well, where every state assistance program is, well, every public assistance program is managed at the state level. So having something that is a tool where we can define logic, where the core aspects of what the rules are doing is common between them, thus being able to kind of modularize to different sort of state use cases, while also recognizing that there are very specific programs depending on the state, be them poverty level, thresholds, etc. Corticon allows for us to define discrete units of logic that can be built upon together, tweaked as their own units separate from one another, all the while understanding how a change here might affect the output later on when we actually run these rules. So ultimately, beyond just the ability to adhere to the regulatory labyrinth of what state allows what for auto insurers, whether auto insurers or otherwise, to the extent that an enterprise is adopting just automated decision-making technology, really the business, not only from the regulatory standpoint, but likewise from a competitive standpoint, increasingly needs to be able to demonstrate how did we reach a decision? How was this automation that produced the decision built, and upon what factors was the decision made? So ultimately, insurers, but just about every other enterprise these days, needs to be able to explain how a decision was reached. So let's see in action how this screen grab I grabbed from a random insurer in Ontario might be implemented with Corticon. So this is one page of probably an 80-page rate document from this Ontario-based insurer. This one is specifically for a mature driver discount being applied to a policy, and that P.O acronym is primary operator. So if the primary operator of the vehicle is between 50 and 54 years old, then set the discount to 5%, and so on, contingent upon a few other asterisks like at-fault accidents or things like that. So let's take this and say, as the potentially policy underwriter, someone who is again familiar with these sorts of terminologies and underwriting factors that are necessary in implementing the rules explicitly specified in this spec, how we can implement these rules without needing to be coders, just needing our know-how of underwriting. I'm not going to go to questions now. I'm going to actually go to the actual application. Now, what we're looking at here is, let me just move this out of the screen. What we're looking at here is what we call the rule vocabulary. So similar to how in MarkLogic, we can constrain or unify all of the different data points into a unified data model upon which we're going to have a really interoperable interface to use and operate upon data that has been incorporated from various different sources. We're going to, in Corticon, use a data model representation that we call a rule vocabulary. This can be generated from, say, a MarkLogic schema, a relational database schema, or a REST endpoint JSON structure. in order to capture things like the various entities a driver has a coverage or various different vehicles, the attributes about those entities, such as a driver's age, the base rate, date of birth, and the associations between them. So these little carets representing that a driver has a one-to-many relationship with vehicle. Maybe I wanted to add another association to coverage. I could define it as such, or I can add additional entities and build my data model manually versus generating it from that inferred structure. But this rule vocabulary, in the same way that a MarkLogic data hub is going to enable you to have a much more unified view of data that might be of various different structures at the start, this rule vocabulary is fulfilling a similar function of representing all the data in one place, the data that's going to be coming in at the onset of the decision being made. So based upon the vehicle itself, is it a Saturn or not? The data that will be produced as a result of the decision. So is eligible or is high risk of theft equals false in that case. But also all the data that might potentially be retrieved from those external data sources throughout the development of the rules, as I mentioned in that previous slide. So the rule modeler here doesn't need to know or be concerned with the variability of the data source itself, as far as if a database is made up of data that is frequently changing, if the rules are operating upon data that is coming from various different sources. Typically what will be done from the end user perspective as far as the breakdown of roles is IT takes a much bigger role in the creation of the rule vocabulary, because this is really the scaffolding of everything. But from there, the rule modeler only needs to be concerned at the rule vocabulary level. They need to be, they're the ones most equipped to be defining how the conditions of what data field, when it has a particular value, what should happen to other aspects of the data. They shouldn't be worried about the maintenance or the kind of dispersal of the data sources and the data types coming in. They want to be able to implement the rules that are operating upon that data. So really separating rules as its own layer here. Now, once we have this rule vocabulary defined, it's going to live over here on the left hand of our screen. And what we'll be doing is dragging and dropping from our rule vocabulary into what are called rule sheets. So if I open up my rule sheet for this mature driver discount use case, let's take a look at how to understand what is being implemented in this interface. So again, this rule vocabulary now is going to be over on the left-hand side. I'll be dragging and dropping as needed. But the way to look at this decision table interface sort of thing is essentially every column is its own discrete rule made up of any number of conditions that produce any number of actions. The way to read it is when this field meets the condition defined here. So if driver age is between 50 and 54 or 74, then we're going to assign the value of 5 to the mature driver discount percent. We're likewise going to say that they are indeed eligible if they are within that threshold. And what I have up here or down here in the rule statements, these are going to be essentially natural language descriptions of the rules that fire. So when they fire and only if they fire will I get this description of that rule. So it's very easy to trace back why a given output was produced and document what the nature of that change based upon that rule statement, what the nature of it was. So when rule 1 fires, which we're going to implement here, so drivers over the age of 65. So I already have my driver.age dragged in here, but let's also drag in the Boolean for count of at-fault surcharge accidents. So when they are over 65 and they are a principal operator, note that because this is a Boolean attribute, something I specified when I was creating the specific attributes upon this driver entity, I assigned it to be a Boolean data type. So Corticon is going to infer that obviously there's only 2 options here. And when that option is true for this particular field of driver.is principal operator, we're going to assign the value of eligible to the eligible for mature driver discount. And likewise, let's, on the second one, say that when drivers with any at fault, so anything above zero for, anything above zero for the number of at fault surcharge accidents is going to result in an ineligibility for the program. Now, I mentioned how we have all sorts of ways to test early and often with Corticon. So what we have the rest of the way in these other rules so far, which again, the way to read them is when these conditions are met, meaning driver.age is one of these, as well as this field is true for eligible mature driver discount. We're assigning these values as well as sending back the explanation of the rule in these natural language descriptions. So all I've done so far is just to implement those same rules that we were seeing back here, defining conditionally based upon the primary operator's age. Now, hopefully the rule modeler implementing these rules by virtue of being an expert or underwriter in the field versus someone less experienced in underwriting, more experienced as a developer, they are optimally suited to be able to catch potential logical discrepancies in the rules throughout the implementation. But likewise, they're best equipped to be able to resolve cases where Corticon points out those logical inconsistencies for them. So as we take a look at kind of a broader view of these rules, and let's just say, let's just condense this so we have everything on screen. Before I even get to the phase where I can start to, well, before I even care to get to the point where I'm going to pass in some test data to see if indeed when a driver is greater than 65 and they're the principal operator, that I am indeed getting this value of true for eligible mature driver discount. Before I do that, Corticon can infer things just upon the nature of the logic that's been constructed thus far to point out for us if we're going to run into an issue, it can already see it. We don't even have to test yet. So up here, I have my logical integrity checks. So as they sound, just as we have a lot of ability to refine and master data within MarkLogic, we have a lot of abilities to refine and ensure that there's no discrepancies in the rules in Corticon. So if I check for logical loops, we're seeing here that there is indeed a logical loop by virtue of the fact that I'm saying when somebody is when somebody is over 76, I inferred based upon this slide that the discount is 0. So effectively, they may as well be ineligible. So what I've done is say if they are greater than 76 and they're eligible for the mature driver discount, because that was set over here by virtue of them being over 65. Well, in fact, if they're greater than 76, they may as well be ineligible because the mature driver discount percent is 0. So how is this going to be resolved? Corticon wants us to fix this because otherwise we might run into issues as far as unexpected behavior at runtime, but also just these are more expensive issues to fix later on in the development cycle, even if we caught it in the rule testing phase in Corticon, let alone if we actually went ahead and generated this into runtime code. So let's say that this is a bit wonky to assign them to be ineligible if indeed the policy document is saying they're eligible, but it's at 0. So we might go back to our supervisor to get some specification on that, but at least we're going to have a very clear understanding of how that behavior is going to impact the runtime of Corticon. So if they're ineligible, let's just say they are no longer. And in fact, if they are, let's just say that they can only be between 65 and 75 in order to be eligible at all, thus rendering this effectively unnecessary. Now, let's say we want to check now for completeness. So what we're saying here is, are there any permutations of these conditions that could be inferred based upon the rules as have been constructed thus far? So based upon all these and the fact that I was a bit lazy in terms of not defining fields here, fields here, fields here, Corticon's saying, well, you didn't say it couldn't happen, that these combinations of events might happen, but you didn't tell me what I should do when I do encounter that scenario. So essentially, what I, as the rule modeler, can do, again, I should most likely be the person best equipped to be able to resolve and know how the application should behave when this combination of events is encountered. I just need to tell Corticon what to do when that situation is encountered, or I can be more specific here to make sure I'm covering all those scenarios. So we'll skip that for now. But let's just check that last integrity check as well, which is going to check for conflicts. What does that mean? Well, that means by virtue of the fact I didn't fill this cell out, didn't fill this cell out, it could be inferred again that what happens if these things happen at once? What if I do have somebody within the eligible age group who is the primary operator, but is over 0 for the count of at-fault surcharge accidents? Perhaps it might be an even more convoluted rule sheet within which I'm defining these rules, and it might be harder to identify on the onset how that conflict is being detected. Corticon can actually populate out every possible combination that it has inferred is possible based upon the rules constructed thus far, and essentially saying, this is how you messed up. This is the specific combination of events that you did not define effectively enough, because you're saying in one case, this and this will lead to this, whereas in another, you're saying that the same combination of conditions will lead to a different outcome. I can even filter based upon these overlapping conflicts as well. Now, the way to resolve this could be to either be more specific and essentially do indeed define all of these different cells, or I can likewise just override rules and say no matter what, if they are over 0 for at-fault surcharge accidents, let's say that alone is going to overrule them as being eligible. So primarily 1 here, but also probably the rest of them as well. So let's just say 1 actually. That alone will define that when these two are at odds, I will never be assigning the value of false. Therefore, it'll never happen that I'll encounter conflicts down the stream. Now, just to wrap up in terms of the 4 main things that we work with in Corticon Studio, what we've covered so far is the rule vocabulary, the rule sheet, which I'm in here. Last aspect of the rule sheet that we didn't get into is just these rule operators, such as this greater than symbol, for which there are a pretty substantial number of operators where we can parameterize the conditions, not just on individual instances of attributes, but also things like collections of entities. So what if I want to define, say, a discount level if the size of the associated coverages with this driver is greater than 2? Maybe I want to define an umbrella policy discount. Well, I have these collection operators, which can allow me to operate upon collections of data. So I can operate upon the values found within the child associations of these entity records and things like that. Well, these are 2 of the 4 files that we work with. The third is where we do actually define these test cases, where we can start to actually see whether or not the input that we're defining is producing the output that we would expect. Let me actually start with this empty, but to show how it's the same dynamic here, wherein I have defined these pre-built values already, but all I did was drag in a driver, assign the values for various different test cases, and run these rules in order to see how the rules are going to behave at runtime. Because what happens when I actually execute these rules will be Corticon is going to generate the rules into the same runtime code that it would generate had I skipped ahead to actually generate the code. So I can get the precise behavior and the view of the order of events of how these rules are going to be evaluated without needing to go to that deployment step. I have this whole test case builder right here. And when I run it, it's going to generate these rules into that JavaScript bundle. I'm using the Corticon.js flavor of Corticon, meaning I'm going to run these rules as JavaScript as opposed to Java. And what we're going to see is that by virtue of these input fields, I have found, at least for the rules where I have explicitly defined that someone is eligible or not, because bear in mind, I did not ultimately define the actions to take for those incomplete scenarios. So only these 2 are going to produce the actual output that have been defined. I can see in bold the values that have been changed or created as a result of the rules, as well as these dynamically populated rule messages, which were defined as rule statements earlier on. Now, if I'm probably not going to be using Corticon more than a couple times for the initial development versus maintaining these rules over time. So oftentimes users will want to understand how a policy change might impact the rates or the approvals that they're seeing for their applicants, or pick and choose and lift and shift that use case analogy to a different industry. We'll want to see how the expected behavior compares to the output in the cases when we do make changes for what if scenarios, or just validating whether or not we've implemented it and produced the output as we expect. So for whatever reason, I expected this driver number 3 to be eligible when in fact they were not. I could run the test and start to isolate out the values and the areas wherein I'm producing results that are not in line with the expected outputs. One other thing to cover on this page here is the fact that I'm not necessarily limited to try to trace back the behavior of these rules by reading through my rule messages, and hopefully the rule modeler was diligent enough to write out these rule messages, but we're not necessarily entirely dependent upon them for having done so in order to trace back why a decision was made in the way it was at the point it was, when in the decision that aspect of the rule execution behaved in the way it did. We can actually run this test with rule trace, which now, instead of just sending me back these rule messages, I can see how every change to this payload happened over the course of the execution of this test case. So 4 different things happened. In this case, I'm just testing one specific rule sheet, but I can see the order of events of how this rule sheet was evaluated for each of these drivers. You can see how driver 4 had 3 different rules impacted or make change to them or evaluated upon them. And likewise, I can see the specific rule in which rule sheet, again, this here being the rule sheet, that has produced that given output. So if I double click it, I can go straight to the actual rule within that rule sheet that generated that particular area of the output. So I can isolate out again and really filter down into the rules which produced the aspect of the change that I might want to revisit and better understand. Now, the final file that we handle in Corticon is what we call a rule flow. So what I've been showing in that preceding pane there and within this view here, this is a rule sheet. Obviously, in a enterprise type of decision, we're going to have much more complexity than what's illustrated in these 10 rules. Typically, we'll have any number of rule sheets, could be in the hundreds, thousands, but it really is up to the user how they would like to separate out the logic into these discrete decision tables. But what the rule flow represents is I have dragged in all my various different rule sheets, connected them within this canvas here, and this is going to define the order of events of what takes place over the course of this evaluation of these rules. So Corticon itself is completely stateless. There's no data stored in Corticon. Obviously, we've been working off of references to data fields such as driver.age, not 65, the value. So what we're doing is defining how we're going to change data when it is passed in at runtime. The life of the data is only during the duration of the processing of the decision. And so within the processing of the decision, it might be received with an initial set of input data up front. It'll be changed by some rule or another over the course of this and then this. And we're continuing in memory. All the changes made here will correspond to the data passed in at the onset to this rule sheet, then this rule sheet. What we see here is actually branching down into different sets of rules that might be applicable depending on the geography of the auto insurance applicant. So depending on the field value for their, say, residence territory, we're branching into rules with rates specific for that territory, and then carrying through to our final rule sheet. But this general workflow is going to then be generated into the runtime code. In this case, I might want to package these rules into the runtime code such that I can run either the rules directly within a web browser, but the point with this deployment option with JavaScript is it can run wherever JavaScript runs. There's no dependency upon any external runtimes. It can run in a browser or a mobile app client side. It can run within, say, a serverless platform like AWS Lambda functions or Azure or GCP functions. or we can run directly within MarkLogic. And essentially, this will allow us to operate upon the data that has been maintained and curated within MarkLogic, make any changes, and persist it back to MarkLogic right there within the context of it. This is exciting for us because we also get to kind of inherit in this way all of the security and privacy controls available within MarkLogic. So by virtue of running these rules directly within that context, you can be sure that you're able to implement these complex decision-making capabilities without running afoul of the certifications for security and everything that comes out of the box with MarkLogic. Because ultimately, all of the rules are encapsulated in just the JavaScript that's going to be run entirely within the context of MarkLogic. But just to show as the quickest illustration of what that runtime might look like, let's quickly actually show the, I'll just put this in my downloads, produce this JavaScript bundle for the browser, because what I can now do is see precisely how these rules might behave at runtime. So if I go back quickly to my rule test case, I can export the JSON to clipboard because, again, very similar to how the rules are going to behave at runtime, we're generating the decision service in the background here. And so when I execute it within the rule Corticon Studio, or say within the browser, now that it's been generated into a rule flow, if I open up my browser sample here, which is essentially just going to be a basic example of executing rules client side, I can paste that input. You can see it's the same general idea as what we saw a moment ago. And at a click of a button, we have these already generated outputs based upon those rules, lightning quick, because the entirety of that evaluation wasn't dependent on any call to some server elsewhere or a library elsewhere. It's running as pure JavaScript embedded directly within my browser here. The last thing that is worth pointing out is I can even change the actual invocation code within this within here to be able to say, beyond just having these outputs as well as the rule messages that correspond to the outputs, maybe I want to have a better view into the actual order of events like I did within that rule test rule trace. So here, this was relatively underwhelming as far as the amount of data that was produced, but commonly we'll have rule sheets that generate or rule tests that will, when run against an entirety of a full rule flow, hundreds of things might be taking place as far as the sequence of events and the different changes that are affecting a payload over the course of its evaluation as a decision. So we can actually tweak the handler that is invoking that decision service in order to receive back as part of the response payload, as we saw in the browser. We can include all of that rule trace data to be able to, again, troubleshoot, but also do things like analyze how different rules are firing more often or less often than in the past. We can persist all this directly back to MarkLogic, so we can produce some good analytics and visualizations based upon rule behavior and common paths to being determined eligible for a discount or otherwise, but also just improve upon the validity of the decisions being made by capturing not just the inputs and outputs, but likewise the paths through which the given decisions are being evaluated. So again, as of today, that is the actual release date of this version of Corticon.js, which has that target runtime of MarkLogic. So we can run these rules directly within that MarkLogic context, as we could with those other environments as well. So this has been a kind of breeze through the high-level aspects of creating a decision service from business rules in Corticon. The amount of things that you can do, the use cases available to you within Corticon, as illustrated in terms of the kind of very widespread customer industry base, is really allows for a whole lot of different things to be implemented. So essentially, it comes down to a matter of complexity of the use case, the decision being made, and the preference for people who are skilled knowledge workers that are not one and the same as application developers, the extent to which those are the individuals who should be the ones implementing and maintaining, ultimately documenting the rules that oftentimes are very impactful and have high consequences upon the organization itself, but also downstream end users. So I'm going to leave it there and open it up for any questions if there are any.
Thank you, Seth, for that. Thanks for that deep dive into the tech that you guys have got, especially that integration at the end with MarkLogic. I think that allows businesses to kind of abstract that business logic, those business rules, out of MarkLogic and into a user-friendly UI. So I think that's really impressive. Just a few. We might go a little bit over time. So if you've got to leave, please feel free to check it out on demand. But we'll go through a few questions. Where do businesses get started normally with these things then? Because you know, we have the same question with Semaphore, which kind of abstracts that data logic. This is the business logic. So where would businesses traditionally get started when they're looking at trying to use Corticon?
So there's kind of different segments to that, how customers really onboard themselves, and it depends upon what led them to Corticon in the first place. So sometimes businesses are just looking to make greater use of serverless technologies. Probably they're not coming from other serverless implementations like AWS Lambda again, but they're looking for a way to create complex functions like what we're showing here, while capitalizing upon the kind of all the benefits of serverless, like not needing to maintain availability and the underlying infrastructure. So Corticon is a great entry point for use cases like that, where it's tailor-made for generating the code for those serverless platforms. Likewise, if you don't necessarily have a lot of in-house JavaScript talent, but you do have MarkLogic and you would like to make better use of the data that is made available from MarkLogic, Corticon's a great way to be able to operate upon that data within the context of MarkLogic as JavaScript. But oftentimes it's much less glamorous as far as the transition to using a system like Corticon, because typically you're not starting with Corticon. Corticon's used in 31 different state governments, and almost all of those were for use cases that oftentimes still do involve COBOL applications, very heavy server infrastructure that hasn't changed in a long time, in which case it's always easiest to start piecemeal, particularly when, say, there's a new governmental assistance program that lends itself to a net new development project to demonstrate out how Corticon can improve and build upon the kind of in-house capabilities already available within the labor force versus needing to find a COBOL developer. So there's a lot of avenues through which you might ultimately start to use Corticon, but because of the way in which it is very, the benefits and what you build with Corticon is very, it builds upon itself. So the rule vocabulary can continue to expand, the use cases can continue to expand, but you're never going to create something that will later be incompatible with Corticon or anything else. It's a very incremental type of development pattern already. So it's not an all at once sort of proposition.
And I mean, we talked a lot about the insurance use case, and I know you briefly sort of touched on the governmental use case, but have you got some sort of high level examples of implementations in other verticals that might be there?
Yeah, so to give a breeze through of some of the more recent projects that we've worked on. So for example, with Corticon.js, I mentioned how we can run these rules directly within a web browser. So that's opened up possibilities and actual production use cases now of dynamic forms. So reacting to user inputs when a user says that, and I'm going back to insurance, but for illustration's sake, say they're filing a claim, what type of claim is it, going down different paths depending on their answers to questions. That has opened up possibilities within commerce, within supply chain use cases, routing of field service inquiries. Likewise, we've been doing more and more in the energy vertical. So the notion of criticality is very important within the energy infrastructure world. Criticality essentially means evaluating the risk level that something bad will happen to, say, a electric transformer or a substation. So rules are evaluating on a constant basis with a few of our customers the various different parameters that are evaluating risk factors of the age, the surrounding population, how many hospitals, for example, might be operating off of a substation. That's an area where there's a lot of sophisticated calculations going on. And finally, this is certainly just another example, not rounding out the entirety of them, but within the financial space, both for, say, loan origination sorts of use cases, but also for clearinghouses, for securities, optimizing things like ensuring that the types of transactions or security acquisitions are not subject to, say, day trading restrictions or credit card usage, fraud monitoring use cases like that. So pretty much wherever there's complexity, you'll find Corticon. It just so happens that the most regulated industries naturally are where we tend to focus a lot of our demo material, because that's where it typically leads us.
And you know, we've got some very large businesses that we deal with in these complex enterprise environments. Is there any limitations on sort of building and running these rules? Have you come across any sort of hard limits or anything like that?
No, so it's a good question. What's nice with Corticon is, by virtue of the fact that there's no data being stored, really you're only the only thing you're building is rules. It's rules that are going to be operating upon, could be terabytes of data, but the rules themselves certainly aren't terabytes. The limitation as far as the volume of rules being evaluated over unit time, over unit quantity of rules, or unit size of a given record that is being evaluated, like one driver with 1,000 different characteristics. The limitation is really just upon the underlying infrastructure that is made available to Corticon. Corticon's totally stateless, and it is also scales linearly because of the fact that you might have noticed that on the first time I ran a rule test, it took a moment of that little spinny wheel to generate that decision service. But then you'll recall that within the browser, it was lightning quick. That's a unique thing to Corticon as compared to other rules engines. Essentially, the point at which the most complex computation is happening is when we're generating that decision service, because what's happening then is Corticon's essentially calculating every possible outcome that could possibly happen at runtime, so that when it is encountered at runtime, it's already solved for. It's lightning quick. That means that as the rules get more complex, you're only adding the time of that initial compilation, but the time to actually evaluate those rules is going to be entirely dependent upon if you add more underlying compute to a server infrastructure, then you'll get an equal, exactly linearly scalable amount of additional compute reduction in Corticon's performance.
Yeah. One thing, and we talked about this offline, but I want to bring it like to the audience. What was it like building out Corticon.js in MarkLogic? What was it like developing that particular integration?
Yeah, so Seth, I'll speak to that one.
Perfect.
So the it's actually really interesting. We were talking about it right before this webinar started, that when we set out to do the integration of Corticon.js with MarkLogic, we had all sorts of concerns. There were going to be barriers that we didn't anticipate to it working as we envisioned. It turned out none of those barriers emerged. It was, by many respects, a very easy integration. The primary change that we had to make to Corticon.js was to generate synchronous JavaScript code, which, if we go back to an old enough version of Corticon.js, it was synchronous. So the change we had to make to Corticon were actually very minimal, and the integration with MarkLogic went extremely smoothly. I wish we could say all of our, any platform we integrated with was as easy as that, but it was by far the smoothest. And that's a testament to a few things. One is the maturity of MarkLogic as a platform and its JavaScript support. They've got a robust, very rich JavaScript API there that we're able to tap into. But also with from the Corticon perspective, the JavaScript rules being fully self-encapsulated, no external dependencies. It's just a natural fit to be able to take a JavaScript bundle that was produced with Corticon and deploy it on MarkLogic. It was, all the integration patterns we want to achieve, we were able to demonstrate really quickly. It just worked really well. There wasn't any sort of big hurdles we had to overcome to do it.
Yeah, no, it's interesting to see the integration of the technologies into more of a data platform piece. So, we've got MarkLogic, we've now got Semaphore dealing with that data in context. And that's how I think about you guys, is the Semaphore is doing that data in context. I think Corticon's doing the business rules in context.
Yep.
It's applying that to the data, to the underlying data. I love the rules trace facility in there, not just for faults, but obviously then how you made those decisions, which is important, especially for regulated businesses, where a regulator comes in and goes, show me how you got to this. You can take that approach and show people, well, these are the rules, this is why we did it, these are the decisions we made. I think that's really interesting for a lot of our customers in those heavily regulated spaces.
Yeah.
I
was just going to say, with Corticon.js, that we were able to run the JavaScript directly on MarkLogic. Your business rules, your business logic, it's close to the data. So whether you're doing, it's some sort of low latency transactional use case where you have rules fired to in response to some document that was updated, and you need to quickly get the response back to some sort of client, you can do that. Or if you want to do batch use cases where you've got lots of data inside of MarkLogic that you need to process, you can do that very effectively as well with the JavaScript rules running directly on MarkLogic.
Yeah, well, I mean, this has been a great introduction. I know we're running over time, and I'm just respectful of that. So it's been a great introduction to Corticon, and I hope that you found it useful. If you're watching this on demand and you want to ask more questions of Jim and Seth, get in touch. We'll put you in contact with them, and you can talk about your specific use case or your need. I just want to say thank you very much, Seth, James, Stefan earlier as well for joining us for this month's community webinar. It's been really interesting to learn more about our overall product suite that we have in Progress, including Corticon, and with that great integration now with MarkLogic. It's just another way of making sure you can get the most out of your data. So thank you very much, gentlemen. Thank you for joining us today. Please feel free to sign up for next month's May community event, and also join us for our live MarkLogic World in Amsterdam, where you'll be able to see some of us in person. You'll be able to ask questions. We've got a number of presentations, both from our customers and from the guys here as well. So so it should be a good event. Once again, thanks very much to the speakers. Thanks for joining us today, and we will see you in the next one. Thank you very much.
Thank you, everybody.
Bye.
Thanks, everybody.
Bye-bye.